Welcome to Mr. Garofalo's podcast for dividing numbers in scientific notation. Today's episode, we're looking at problem number 2, part D, which is 6 times 10 to the 11th times 4 times 10 to the 7th divided by 3 times 10 to the 5th. So I chose this problem today because we did not do a problem like this in our class examples. What's different about this problem from the ones we did is that we have the product of two scientific notation expressions in the numerator. And then we're going to want to divide that by a scientific notation expression in the denominator. So we'll first have to use our knowledge of multiplication before we can start dividing. So our coefficients here, 6 and 4, will be multiplied. And of course, we'll be multiplying our powers of 10 as well. 10 to the 11th times 10 to the 7th. So our numerator could really be reordered and regrouped by the commutative and associative properties to look like this. And that's all going to be divided by 10 to the 5th power. So let's go ahead and do that multiplication. 6 times 4 would give us 24. 10 to the 11th times 10 to the 7th. Remember, we're going to keep our base and add our exponents here, since we have the same base. So this is really 24 times 10 to the 18th divided by 3 times 10 to the 5th power. Now that we have a single scientific notation expression divided by another scientific notation expression, let's go ahead and do the division. This works out great. We have a multiple of 3, so 24 divided by 3 would give us 8. And then for our powers of 10, now we're dividing, so we're going to keep our base, 10, but subtract our exponents. 18 minus 5 will give 13. And that's it. We now have a final answer, 8 times 10 to the 13th. This number here is less than 10, greater than or equal to 1. So it fits the criteria for scientific notation as a coefficient, and we have that being multiplied by a power of 10. Let's take a look at another problem. This is problem number 3. This is a problem that involves distance, rate, and time. We're told that a spacecraft leaves Earth traveling at 700,000 kilometers per day. Well, that's a speed. So that's going to be the rate in this problem. At this speed, how long will it take to reach Saturn, which is 1,400,000,000 miles away? So that's our distance. So in class today, we learned about the distance formula. That's distance equals rate times time. What we'll do is abbreviate each of these numbers and replace them in the formula. So the rate, 700,000, would be 7 times 10 to the 5th power. The distance would be 1.4 times 10 to the 9th power. And then we'd be solving for t, time. So this is a multiplication equation, which means to solve it, we're going to need to use some division. So we're going to divide both sides by 7 times 10 to the 5th. Divide by 7 times 10 to the 5th on the right side, and we're just left with t, time. Divide by 7 times 10 to the 5th on the right side. This is a 9. Let me fix that. All right, why don't you pause the video and try and do the division on the left side here. Hit play when you're ready. So how did you decide to divide this? Did you make an adjustment to the number 1.4? If you did, you could make it 14, and that might make the division a little easier. It would look like this. 14 times 10 to the 8th power. If we move that decimal one place to the right, subtract 1 from the exponent, and look at the benefit we have now from that. Since we're not using a calculator, we have 14 divided by 7, which would give 2. And then we're going to keep our base and subtract our exponents. 8 minus 5 would give 3. So t is equal to 2 times 10 to the 3rd power, which would be 2,000. So it would take 2,000 days for the spacecraft to reach Saturn. I hope you found this helpful. Please add these to your homework notes. See you in class.